Today we're going over how to solve Newton's second law problems on inclined surfaces. So anything that really involves an angle. So let's look at this problem real quick. We have a box on a ramp and it is sliding downward. However, nothing is pushing it. There's no external force. So if we were just to look at it, we know that there's weight going straight down. We have the normal force going up, perpendicular to the ramp, and that's it. Those are all the forces acting on the block, yet, however, the block is still in motion, right? The block is still moving. So let's draw a free body diagram for this block. So I'm just going to draw it also inclined. We have our normal force pointing up. We have our weight force pointing down. However, we don't these forces are not opposite each other, which makes it a bit difficult. But one thing we should recall is that force in Newton's second law is a vector, right? And vectors can be broken up into components, right? So if we have our coordinate system of x and y, we can break this vector of w to be w perpendicular and w parallel, right? Perpendicular because it's perpendicular to the ramp, parallel because it's parallel to the ramp, right? So now we have weight force is equal to w perpendicular plus w parallel, and that is just basic vector addition that you hopefully learned in math class. But this is how we can take any angle object, split it up into components, and solve from there. However, we don't actually know what weight perpendicular and weight parallel is. So that is where we account for the angle. So let's look at F parallel first, right? We know that weight is just mg, right? Gravity. So we're going to say, oh, sorry, this is not F. This is supposed to be W. There you go. So we know that weight is just mg. However, now because this is at an angle of theta, we can make a triangle from this, right? So M parallel here. So this theta is equivalent to theta here, right? Those thetas are the same due to law of triangles. So W perpendicular is opposite of theta, and we know that a side opposite of an angle can be written as sine theta. So we have W parallel is mg sine theta. And similarly, we can say that W perpendicular is mg and it is adjacent to the angle. So this would be mg cosine theta. And that is how you apply angles to forces that aren't up, exactly up, down, right, or left. All right, so let's try an example problem. If you want to pause the video and try it on your own, please do so, and then I will work it out. All right, hopefully you had some time to work out this problem, but I'm going to go ahead and show you how to do it. A 2-kilogram block slides down a 30-degree frictionless ramp. Find the acceleration. So first things first is let's always draw. Physics is very visual, so always try to draw I don't know why it was a circle. So we have a box sliding down a ramp. The ramp is 30 degrees. So I'm going to call that theta is 30 degrees. We have our block is 2 kilograms, so mass is 2 kilograms. And we want to find the acceleration. So our first step after we draw everything is to draw a free body diagram of the block. So we have block like this. We have normal force going up. We have weight force going down. And because it's at an angle, I'm going to draw this to be, I'm going to split it up into weight perpendicular, weight parallel. And that's it. It's a frictionless surface, so there's no friction force here. And that's our free body diagram. So I'm actually going to draw the coordinate system to be like this. So x is in the direction along the ramp, y is perpendicular to the ramp, just to make it easier. So let's write our equation. So sum of forces in the x direction is equal to mass times acceleration in the x direction. And I'm choosing x direction again because the box slides down the ramp, which is in the positive x direction. I can write the same formula for y direction, but there are no forces causing acceleration. Here, actually, let's work that out real quick. So we have sum of forces in the y direction is equal to mass times acceleration in the y direction. We have forces in the y direction, which is normal force minus the perpendicular of weight is equal to mass times acceleration in the y. However, we know there is no acceleration in the y, so ay is 0. So this whole side is 0. So we know that normal force is equal to weight perpendicular. But there's no acceleration there. So we want to find so we're going to use this formula only for the x and ignore that. All right. So we have forces in the x direction is equal to mass times acceleration in the x. We know the forces in the x direction is just weight parallel. So we have weight parallel is equal to mass times acceleration in the x. And weight parallel from above is just mg sine theta, right? So we have mg sine theta is equal to mass times acceleration. And now let's plug everything in. So we have mass is 2 kilograms, theta is 30 degrees. So we have 2 times 9.8 times sine of theta is 30 degrees is equal to 2 times a acceleration. And once we simplify everything, get everything to one side, we are left with acceleration in the x direction is equal to 4.9 meters per second squared. And that is the answer. Oops. So notice how we don't have anything explicitly pushing the block straight down like that. We just have the weight force pushing down, but not the entire weight force, only a part of the weight force, and that part is the weight parallel. And using the weight parallel, we can see how it moves the block down at an acceleration of 4.9 meters per second squared. So I hope that helps. And yeah, I'll see you next time where I'll be doing a video on tension problems and applying Newton's second law to those types of problems.